Hello students, welcome to Dr. CHANDAN MOHANTY classes. This video I will be discussing about method of residual for estimation of Ka. Ka, as we know, absorption rate constant. There are two methods to estimate this Ka. For one compartment model, there are two methods how this Ka can be estimated. Number one, method of residual. Number two, Wagner Nelson method. Regarding this Wagner Nelson method, already I have made a video. That video I have given in the I button. Also that video link I have given in the description. So what is this method of residual? We will discuss in this video. The contents are other names of method of residual. What are the various names of this method? We will discuss. Then step-by-step method. What are the steps by which this Ka can be estimated? We will discuss. Then what is flip-flop phenomenon? In this method of residual, there is a flip-flop phenomenon. What is that phenomenon? We will discuss. Then what is lag time? Time lag. We will know. Then last, disadvantages of this method of residual. So these are the contents which we will discuss in this video. So without delaying much, let's start. This method of residual is also known as method of feathering, method of peeling and method of stripping. So there are three other names of this method of residual: feathering, peeling and stripping. Now we will start steps. What are the steps by which Ka can be estimated? So there is an equation: C is equal to Ka Fx naught by Vd Ka minus Ke into e to the power minus Ket minus e to the power minus Kat. This equation is for one compartment open model, extravascular administration, first order absorption. In this equation, C, as we know, plasma drug concentration, Ka absorption rate constant, F bioavailable fraction, x0 amount of drug in the body at time 0, Vd apparent volume of distribution, Ke elimination rate constant. So all these things we can take as a hybrid constant A, because these all are constant or number. Ka is a constant, F is a number, x0 is a number, Vd is also a number, Ke is constant. So all these things we can take as hybrid constant A. So this equation 1 will become C is equal to A, means this, into e to the power minus Ket minus e to the power minus Kat. So if you will open this bracket, it will be C is equal to A into e to the power minus Ket minus A into e to the power minus Kat. Let this be equation number 2. Now during elimination phase, you see this graph. This is absorption phase, this is elimination phase. Left side is absorption phase, where rate of absorption is much more than the rate of elimination. And in case of this right side, rate of elimination is more than the rate of absorption, because here the absorption will not be that much. The rate of absorption will be less than the rate of elimination. So hence this A into e to the minus Ket will become 0 when during this elimination phase. So this equation 2 can be written as C back is equal to A e to the power minus Ket when during this elimination phase, because this part will become 0 because the absorption will be almost nil. So it will be C back is equal to A into e to the power minus Ket. C back stands for back extrapolated plasma concentration. Here in this graph there are 3 C's. C back stands for back extrapolated plasma concentration. C, our true plasma concentration, our normal plasma concentration, and Cr, residual plasma concentration. So there are 3 C's. This C back is back extrapolated plasma concentration. So this is the equation number 3. Now if you will take the log of both sides of this equation, it will become log C back is equal to log A minus KET by 2.303, and this equation is same like equation of straight line y is equal to mx plus c. In this y is equal to mx plus c, y stands for value in y axis, x stands for value in x axis, m stands for the slope of this line, and c stands for y intercept. So this line y is equal to mx plus c will be same like this log c back extrapolated is equal to log a minus ket by 2.303. Here the y will be log c back, this y axis will be log c back, x axis t, slope minus ke by 2.303, and y intercept will be log a. So this is also a equation of a straight line, y is equal to m x plus c. So y is equal to mx plus c, where this equation slope is minus ke by 2.303. As I told, there are three c's. First one, C back means back extrapolated plasma concentration, C normal or true plasma concentration, CR residual plasma concentration. This CR residual plasma concentration can be obtained by subtracting C means true plasma concentration from back extrapolated plasma concentration. So CR will be C back minus C. So as we have learned in the last slide, equation 2 is C is equal to A into e to the power minus KET minus A into e to the power minus KET, and C back, that is equation number 3, is equal to A into e to the power minus KET. So this is true plasma concentration C, this is back extrapolated plasma concentration C back. So CR will be C back minus C. So in place of C back we will write A into e to the power minus KET, C back, minus C. This we will write A into e to the power minus KET minus A into e to the power minus KAT. So CR will be this minus this, means back extrapolated plasma concentration minus true plasma concentration. So now simple mathematics will apply. CR is equal to A into e to the power minus KET minus this bracket will open A into e to the power minus KET plus, because minus minus it will become plus, it will be A into e to the power minus KAT. These two will be get cancelled because both are equal. So the final equation will be CR is equal to A into e to the power minus KAT. So residual plasma concentration will be equal to A into e to the power minus KAT. Now if you will take log of both sides, this equation 5 will become log CR is equal to log of A minus KAT by 2.303. This equation is same like equation of straight line y is equal to mx plus c. In equation of straight line y is equal to mx plus c, y is the value of y axis, x is the value of x axis, m is the slope of the line which you will get, and c is y intercept. So this line is also equal to this y is equal to mx plus c. So here log CR will be y value, y is equal to mx plus c. Here y is equal to log CR, x t, slope m is minus k by 2.303, and log a will be y intercept. So if we will plot a graph between log CR versus t, log CR in y axis, t in x axis, we will get a slope, we will get a straight line whose slope is minus k by 2.303. So in this graph if you will see, this graph is residual curve, which we will get by subtracting this C back minus C. So this line slope will be minus Ka by 2.303. So these are the steps by which we will get Ka. Ka can be obtained from the slope of residual curve. This slope is minus Ka by 2.303. From this slope we will get this Ka. What is flip-flop phenomenon? Method of residual will work best when the difference between Ka and Ke is large. Means the ratio of Ka by Ke is more than equal to 3. When Ka is large, much more than Ke, then this method will work best. In that case, this terminal linear slope will give Ke and residual slope will give Ka. But problem will occur when Ke is much more than Ka, means the difference between Ke and Ka is large. If this ratio is more than equal to 3, then what will happen? This terminal slope will give Ka, not Ke, and this residual slope will give Ke, not Ka. Here it is written if Ke by Ka is more than equal to 3, then terminal slope estimates Ka, not Ke, whereas this residual slope will give Ke, not Ka. In normal case, when Ka by K is more than equal to 3, this terminal portion will give Ke, residual curve will give Ka. But when Ke is much more than Ka, if Ke by Ka is more than equal to 3, then this terminal slope will give Ka and this residual slope will give Ke. Means these two lines will interchange their values. This is called flip-flop phenomenon. They will change their value, flip-flop. So this is called flip-flop phenomenon since the slope of the two lines have interchanged or exchanged their meaning. So this is flip-flop phenomenon. What is lag time or time lag? Lag time is defined as the time difference between the drug administration and start of drug absorption. It is represented by the symbol T naught. Here you see in this graph, this is T naught or lag time. This time difference is lag time. Here at time 0, drug will be administered, but the drug absorption will start at this point. So this time difference is lag time. This T0 represents the beginning of absorption process. Here the drug will be administered, but the drug absorption will start at this point. So this time difference is called as lag time. Actually, this residual curve and this back extrapolated curve should intersect when the time is 0, means on the y-axis. In that case, there will not be any time lag because the drug administration and drug absorption will occurs at same time. But if the residual curve and back extrapolated curve will intersect any time more than 0, that will be called as time lag. Means there is a time difference between drug administration and start of drug absorption. So this is T0 or time lag. Disadvantages of method of residual. This method of residual will work best when the drug is rapidly and completely absorbed and drug will follow one compartment model. This method of residual will be working only when the drug is rapidly and completely absorbed and it exhibits one compartment characteristic. The problem will occur when the drug absorption will be altered due to any reason. If the drug absorption is influenced by the factors such as gastrointestinal motility or enzymatic degradation, then and when the drug is following multi-compartment model, then this method of residual will not work and it will give inaccurate result. This will give inaccurate result when the drug absorption is altered and when the drug will follow multi-compartment model. So this is the demerit of method of residual. With this, I have completed this method of residual video. Hope you have liked this video. If any doubt, queries are there, please write in the comment box and give your feedback also in the comment box. Very soon I will come with a new more video in biopharmaceutics and pharmacokinetics. Till then, stay healthy, stay safe, keep smiling.